my team's final project, we created an autonomous car with flex resistors and a photoresistors as our two design sensor elements. As you can see, our car looked like this, with the two flex sensors in the front and the photoresistor within the circuitry. The flex resistors acted similarly to the switches, but instead of manually using switches, the flex resistors were added in series so that if the car starts to contact a wall, the flex resistor would bend and increase the resistance to decrease the duty cycle and thus slow down the wheel of the opposite motor, and then the car will be able to turn. That worked both ways for each side. The photoresistor acted as speed balance and speed fine-tuning. So the photoresistor was placed within the circuitry so that the speed could be at balance and the car could slow down at a steady pace and increase at a steady pace when the flex resistors weren't bent, and it increased it added some resistance so that the car did not go too fast when it was just going straight ahead. Another thing about our car is that unbent, the resistance of the flex resistor was 10.8 kiloohms, and then if you bend it 45 degrees towards the end of it, since the flex resistor doesn't bend at the front, it's 14.2 kiloohms, and then if you bend it 90 degrees all the way, if it's doing a sharp turn, the resistance is 22.0 kiloohms. This increasing resistance shows, at the variations of bends, shows how the flex resistor acts to create the car at a slower pace. Also, if you look here, this is what the oscilloscope reading is of the V balance when both flex resistors are unbent as the photoresistor is acting. As you can see, they are square waves, which shows that it's functioning smoothly. This is the duty cycle when it is bent for a left turn, the oscilloscope reading. As you can see, the duty cycle has decreased from 44 to 30